So once again I welcome you all. Now this is precisely our third lecture on draft tube. So in past two classes what we have discussed is what is a draft tube, what is like importance of draft tube, what are the systems or what are the types of turbine in which a draft tube is required and why it is required. Okay, then in the second class we discuss about how to find the efficiency of draft tube, how to find the pressure head at the inlet or at the outlet of the draft tube. So these are the things that we have discussed as of now. Today what we will be discussing, in fact today we won't be discussing any theoretical topic. Today we will be solving some problems. So I think I have taken the problems from RK Rajput example itself so that you can relate it to it, and if you have any doubt you can go through it again. Okay, so this is our first problem. Okay, now the first problem, it says this is both the problems are based on draft tube only. So determine the overall efficiency of a Kaplan turbine. So first thing is like you have to find the overall efficiency. Developing 2850 kilowatt power under a head of 5.2 meters. So we have to find the efficiency of Kaplan turbine which is developing a power itna under a head of itna. Okay, it is provided with a draft tube with its inlet 3 meter. It means I told you the draft tube is somewhat like this. So the inlet is 3 meters, set 1.8 meters above the tail race. So 1.8 meters above the tail race. I'll draw the diagram also. So the draft tube is set 1.8 meters above the tail race. Okay, a vacuum gauge connected to the draft tube indicates a reading of 5.2 meters. So the obviously in draft tube we see that the pressure head changes. So when the gauge is connected to the draft tube, the reading that it is showing is 5.2 meters of water. So this is your head that it is showing. Now you have to assume the draft tube efficiency to be 75%. Okay, so ultimately what we have to find by doing all this, we have to find the overall efficiency of a Kaplan turbine. Okay, is it clear? Okay, now let's tackle things one by one. Okay, so overall efficiency, first of all let's write what are the things that are given. So power is given as 2850 kilowatt at a head of 5.2 meter. Okay, this is given in the question. The second thing that is given is, so I'll be trying to write it like this so that we'll try to finish the problem in this page itself. We'll try, let's see whether we finish it or not. Now the height of the draft tube is HS. The height of the draft tube above the tail race is 1.8 meter. Now I'll draw the diagram here itself. Then it will, what is 1.8 meter? So if your draft tube is like this, okay, so it will always be submerged in your tail race. So this is your tail race, this is your inlet of the draft tube, and this distance is given as 1.8 meters. Again 1.8 meter is what? 1.8, the inlet of the draft tube is set 1.8 meter above the tail race. The inlet of the draft tube is 1.8 meters above the tail race. So this distance is given and this distance is known as HS. Okay, we have already discussed in the last class. Okay, now reading on the gauge is, the reading is minus 5.2 meters. Why I am writing minus? Because we have, see, if nothing is given in the question, then the reference is taken as atmosphere. See, the reference is taken as 10.3 meters of water. This is your reference head and this is your atmospheric pressure head. This is the pressure head of water when it is subjected to atmospheric pressure. So this is taken as the reference. Now when it is not given in the question, then we will take this as the reference, and the reading is 5.2 meter and vacuum gauge is given, so it will give you the relative value. So therefore we take it as 5.2 meters and we'll add a negative sign, minus 5.2. okay, now the efficiency is given as 0.75 or 75%. okay, now we have to find the overall efficiency. Okay, see, my approach is whenever I encounter a numerical, I try to solve it in a reverse manner, in the rough, and then quickly if you get the correct answer, come to the examination sheet. But first you try to solve it in the reverse manner, it will be easier for you. So we have to find the efficiency. Okay, so efficiency is power developed upon water power. This is the efficiency of turbine. This we have learned in the second class itself. So power developed is given as 2850 and water power is rho g QH, or you can write it as WQH. Okay, now listen, 2850 it is given, obviously it is given. W, you know the value of rho, the value of G, it is known to us. Head is given as 5.2 meters, so head is also given. Now the only thing that is not given is discharge. So we have to find discharge, and for that we will be using all this, because see, if you remove discharge, whatever the things are required, it is given in the first two lines itself. So why they have given this Ram Kahani? Why all this is given? It is given so that we can find the discharge. Okay, now discharge is again area into velocity. Okay, discharge is Q is equal to area into velocity. Now area, again area is given, area we can find it out. Now our aim is to find the velocity. Okay, or let's see if there is any other way. Area 3 meter, yeah, area. So discharge means area into velocity. So draft tube is like this, and the inlet is given as, the diameter of the inlet is, it is provided the draft tube with the inlet 3 meter. So it is the inlet of the draft tube, the diameter is 3 meters. Okay, so the area is already given. Now the only thing required is velocity. So if we are able to find velocity, we will find discharge, and hence we will put the value and we will get the answer. Question solved, problem solved. Now how to find the velocity? Now we have to apply the formula of draft tube, you know, whatever the formula we have studied in the last class. Now the formula says P2W is equal to PAW minus HS minus V2 square minus V3 square upon 2G minus HF. So this is the formula that we know. Okay, now P2 upon W minus 5.2. So this is the pressure head that is given. Okay, so 5 minus 5.2 PA upon W. Now we are taking this as the reference head or the datum head, so it will be 0 minus HS is given as 1.8 meters minus V2 square minus V3 square upon 2G minus HF. Now again, see, as far as HF is concerned, nothing is given in the question, so we can avoid this term, because this is, see, first of all, even if it is given in the question, the loss due to friction will be very minimum. So when it is not given in the question, you can avoid it. Otherwise you can take some random value, 0.2, 0.1, whatever. But if it is not given in the question, it is like better to just avoid it. You can say that the frictional loss is negligible, so you can omit this value. So this is the form in which you are getting. Now, so upon solving, you will get that V2 square minus V3 square upon 2G is equal to 3.4. Now when you solve it, put it on this side, you will get the value. Okay, now, so this is equation number 1. Now what is the efficiency of draft tube? V2 square minus V3 square upon 2G upon V2 square upon 2G. This is the efficiency. Now efficiency is given in the question, so we have to use that. So we can substitute the value. So if we substitute the value here, then we will find that 0.75 is equal to 3.4. 3.4 is coming from here. See, this whole value is this value. So you can, this whole value is this value. So this is equal to 3.4. 3.4 upon V2 square upon 2G. Okay, now therefore V2 square upon 2G is equal to, you can put it here, 3.4 divided by 0.75. Okay, therefore V2 is equal to, you can take this on the left side into 2G and then take a square root. So you will get the value of V2 as 9.43 meter per second. Okay, I hope till now it's very clear to you. Okay, now the last thing is to find the efficiency. So I'll try to find it here itself. Now see, for finding, you have to do efficiency, you have to do nothing. Just take this value Q. Now V2 is given, you have found the value of V2. V2 means what? V2 means at the inlet. V2 means at the inlet. V2, V3 will be here. So V2 is given, this diameter is given, so you can find area, you know velocity. So area into velocity will give you discharge. So your discharge will be pi by 4 into 3 square, because this diameter is given. Diameter is 3 meters. I think it is given in the question. Yeah, diameter is 3 meters. pi by 4 into 3 square into 9.43. So by this you will get the discharge as 66.65 meter cube per second. Okay, so the value will be 66.65 meter cube per second. Okay, now finally you have to find the efficiency. Just put this value here. So therefore your power will, or your efficiency will be 2850 divided by rho g. You know the value of WH, 9.81, into this value 66.65 into head is how much? Head is given as 5.2 meters. So everything is given, 2850 divided by 9.81 into 66.65 into 5.2. So this will come around 84%. So this will be your answer. Okay, so now I hope this is clear to you. Okay, so this will be your answer. Okay, now yeah, now let's solve the second numerical. Let's solve the second numerical. So the second numerical, it says, let's see what is given in the second numerical. So in the second numerical it is given, let's first read the question. A conical draft tube, conical, okay, remember this thing. A conical draft tube have an inlet and outlet diameter of 1.2 meters and 1.8 meter discharge. So the inlet and outlet diameter is 1.2 meters and 1.8 meters. So if I draw the diagram, it will be somewhat like this. Okay, so this value is so this value is 1.8 meters and this value is 1.2 meters. This is already given in the question. At outlet with a velocity of 3 meter per second. So the velocity is 3 meters per second. The total length of the draft tube is 7.2 meters. So the total length of the draft tube, first of all, total length means from initial to the from beginning to the end. Okay, so this includes the tail race also. So this is the tail race. So total length means it will include the length of the tail race. So from beginning till the end. So 7.2 meter and 1.44 meter of the length of the draft tube is immersed in water. So 1.44 meter length is immersed in water. So this portion is immersed in water. If the atmospheric pressure head, now in the previous question atmospheric pressure head was not given, only gauge reading was given. Here they have given the atmospheric pressure head is 10.3 meters of water and loss of head due to friction, loss of head. Now here again in the previous question loss of head was not given due to friction, but here the frictional loss is given. It is 0.2 into velocity of head. Okay, so whatever is the velocity component, okay, so it is 0.2 multiplied by velocity of head at the outlet. So velocity of head at the outlet, you will find the value of velocity head, you will find the value of velocity head at the outlet and then multiply it by 0.2. So you will get the value of HF. Okay, now gradually we will solve the problem. This will be pretty lengthy problem. Okay, now first of all I think it's better if we draw a proper diagram. So the diagram will be somewhat like this. Okay, this is your draft tube, this is your tail race. Okay, so first of all this length is 1.8 meters, this length is 1.2 meters and then this length is 7.2 meters and then this length is 1.44 meters. So this is already, everything is given in the question. Okay, I hope it's clear to you. This is given, this is given, this is given, this is okay. Now first of all in the initial diameter or the inlet diameter of the draft tube is 1.2 meters. So you can write D inlet or DI is equal to 1.2 meter. Outlet diameter is equal to 1.8 meters. Now velocity at outlet is given as 3 meter per second. 3 meter per second. This is your velocity at the outlet. So it will be V3. Remember this, we have, while deriving we have taken this as 2 area, this as third area. So this is 2 subsection, this is third subsection. So since it is outlet, so it is corresponding to the third subsection. So V3 is equal to 3 meter per second. Now total length of the draft tube, HS plus Y is equal to 7.2 meters. So HS means of Y, HS plus Y. So this is known as HS. This is known as y, if you remember the previous lecture. So hs plus y is equal to 7.2 meters. This is important because suppose if we need the value of hs, I don't know, see I have not solved the problem, but if we need in future, then we can find the value of hs as well. Okay, so the value of hs we can find it. Okay, now see, whenever you are encountering any problem because of this, then just pause the video and read the question, or you can even refer to the Rajput book for seeing the question. Okay, see, obviously you can get the answer from RK Rajput, but why I am discussing it is because if we discuss one or two problems in the class, then you will have a mindset that if a question comes from draft tube, then this is how we have to approach it. Okay, so I am just telling you the path you need to follow. Now how you follow, whether you follow or not, that's your choice. Okay, now okay, so and the length of the draft tube, this length is 1.44 meter. Okay, so therefore hs will be how much? It will be 7.2 minus 1.44 meters, which will be equal to 5.76 meters, and PA upon W is given as 10.3 meters. Okay, now again HF, frictional loss, is given as 0.2 into velocity of head at the outlet. Velocity of head at the outlet, 0.2 into V3 square upon 2G. So these are the entities that are given in the question. Okay, now let's try to solve the problem. Now what we have to find, remember it. First of all, we have to find the pressure head at the inlet. So we have to find P2 upon W. This is one thing that we need to find. The other entity that we need to find is efficiency of the draft tube. These two things we need to find. Okay, so I'll put it here. Okay, now let's try to solve it. Okay, now again see, we have to apply the same formula. P2 upon W is equal to P3 upon W, or PA upon W minus whatever, minus HF, minus HS, minus V2 square minus V3 square upon 2G minus HF, that formula which we have used in the last question. Okay, so here again you need to know the value of V2 and V3. See, ultimately you have to apply the formula P2 upon W is equal to PA upon W minus HS minus V, again put the bracket, V2 square minus V3 square upon 2G minus HF. So this is the ultimate formula that you have to apply. Okay, because this will give you the value of P2W, and this is what we need to find it. Okay, now first of all, in this question, what is given and what is not given? So in this question, first of all, you need to find the value of V2. Yes, V2 is not given because V3 is given. See, PA upon W is given, HS is given, HF is given, V3 is given, V2 we need to find it, and HF also we can find it. So HF is not a big deal. So the only thing that is not given is V2. So we need to find the value of V2. Now how can we find it? First of all, V3 is given. V3 is given. So we can find the discharge. So discharge is equal to Q is equal to A3 into V3, and V3 is A3 is what? Pi by 4 into diameter of outlet square into V3. Now diameter of outlet is given as 1.8 meters. So you can find it, pi by 4 into 1.8 chi square into V3. V3 is how much? 3 chi square. So this will give you the value of discharge. Okay, so it will come around 7.6 meter cube per second. Okay, now one thing always remember, continuity equation, A1 V1 is equal to A2 V2. So when the discharge at outlet, you know, you can also find the discharge at the inlet by applying the continuity equation. So at the inlet it will be again Q is equal to A2 V2. Now V2 is equal to Q upon A2. Okay, now Q you have found 7.634 or something like 34 divided by A2. A2 is pi by 4 into DI square. What is the DI? What is the value of DI? 1.2 meters. So just put the value and you will get the answer. So the answer will be 6.75 meter per second. Okay, now you have found the value of V2. Now put this value here. Now P2 upon W is equal to PA upon W. Now PA upon W is 10.3, it is given in the question, minus HS. HS is what? 5.76, again it is given in the question. Okay, minus v2 square 6.75 square, this is what we have found, minus v3 square, v3 square means 3 square, minus 3 square divided by 2g, 2 into 9.81, minus hf. Hf is one more thing we have to find is hf. So hf is nothing but 0.2 into velocity head. So v3 square upon 2g, v3 is 3, so 3 square upon 2 into 9.81. now you see all the values are given. Now simply you solve it and you will find the answer. The answer will be around 2.769 meter head. Now remember, this will be your absolute value. This will be your absolute head. Okay, when this is given, this will be your absolute head. If this you take it as 0, you will find the relative head. So you have to remember this thing, you have to differentiate between these two. So this will be your absolute head. Okay, so now I hope this is clear to you. So one thing we have solved, the other is efficiency. Now as far as efficiency is concerned, what is the formula of efficiency of draft tube? v2 square minus v3 square upon 2g minus hf upon v2 square upon 2g. Everything is given in the question. v2 is given, v3 is given, hf is given, simply g you know, g you know, so just put the value, find the answer, get off. Okay, so the answer will be somewhat around 76.3%. okay, so everything is given in the question. v2 is given, v3 is given, g is given, hf we have already found out. Okay, yeah, one more thing, yeah, very critical. No, hf also you can find it out, yeah, that's not a big deal. Okay, so this is how you can find the answer. Okay, so I hope these two problems will clear your some doubts, and it will give you confidence also. Okay, because one thing which I observe in my class is that you people are very confident and very happy with theory, but when it comes to numerical आप सब भागने लगते हो. So you should not be afraid of numerical. भाई अब आप अगर जंगल में आ गए हो तो आपको शेर से दोस्ती तो करनी पड़ेगी ना. So once you are in this engineering background, mechanical engineering background, you cannot run away from numericals. You have to love it, whether you like it or not. You have to love it, you have to enjoy it, and the only reason to improve it, the only thing which can improve, how you can improve is practice, practice and practice. Solve as many numericals as possible. ठीक है? So that's all for the day. अपना ख्याल रखिए और अपने बड़ों का भी ख्याल रखिए. ठीक है? Thank you very much.